completed. So did you get the output? Yes, good. Then, okay. So let me share this. So what do you mean by linear regression? What do you mean by linear regression? So linear regression is a basic statistical and machine learning technique, right? And that can be used to model the relationship between a dependent variable and one or more independent variables. Am I correct? And the main goal of this linear regression is to find the best fitting straight line. Y is equal to mx plus c. That is what a linear regression is, to find the best fitting straight line. You may also call it as a like a regression line. So where it explains about like how the dependent variable changes as the independent variable changes. When you are talking in terms of y is equal to mx plus c, so as soon as your independent variables, which is x, in y is equal to mx plus c, so x is the independent variable, y is the dependent variable. So you, as soon as you are going on changing your x value, automatically what happens? Your y value gets changes. So that is what. So how the dependent variable changes as the independent variable changes. So that is what you are calling here as a linear regression. You may have a single linear regression, multiple linear regressions, all these things you have. As already I told you yesterday, like regression performance metrics are mean squared error, root mean squared error, normalized root mean squared errors. All these are the performance metrics. So shall we start? Okay, where it is? Yes. Yes. So for that, you need to import certain packages. Anyway, NumPy is important. You already imported pandas. NumPy is important. And so plot. We want to plot something here. For that, I'm importing matplotlib.pyplot as PLT. And I'm also because Python is a such a wonderful language where you need not to write the pages and pages of the code to develop any kind of model or any kind of a project, because it's all, we have multiple built-in packages. So simply we are using that package and passing your x and y values to that model. Already, like linear regression is a model, so you are simply importing linear regression and passing your x and y values based on your data set, and you are getting the results. That is the beauty of Python, due to which all kind of companies are moving towards to the Python. Okay. So I'm using the model in sklearn. We have a linear model in which I'm importing a package called linear regression. Okay. Now generate sample data. I'm generating the sample data. I'm not importing any kind of data. If you want, you can what we'll call, you can take the data set from the Kaggle and you can use it here. But what they did not mention anything in the question. So my intention is to create the data set, like randomly you are generating the data set and you are playing with the data set. So you should have, like, if you are able to understand this now, you can play with any data set. This is the common concept. Okay. So I am going to generate the sample data. Random. So can you please explain what do you mean by this? Can anyone please unmute yourself and explain np dot random dot seed of 0? Quick. What exactly happening there? What do you mean by random seed? Okay, no problem. I'll explain. A random seed is a starting point for a sequence of a pseudo random numbers. Okay, here you have set a random value which is 0. Okay, so 0 as you set, no? So I'll execute that. You'll be able to understand what can be the output. So if I'll execute this one, and if I'll execute this one, and I just want to display the output, we'll see what happens. So I have taken this, admit, then a random array, how the random array gets generated, you'll be able to understand. And run. I did not executed numpy. Import numpy as np. That is the error. See, what happened? Random seed of 0. So seed value I have given. So based on the seed value, what it is going to generate? It is going to generate a random values. So see, the same thing happened here, np dot random seed. And in that, x is equal to what I am giving? 2 into np dot random of values from 0 to 100. And that too what you are asking here. So when you are executing, you'll be able to understand this. So x is equal to 2 into np dot random dot ran. So you have called a function called ran, and there you are asking to display the random numbers between 0 and 2. And how many numbers you want to display? You want to display 100 numbers. And the same thing here. Why is it? So here what you are doing? You are identifying your x and y values. You are generating sample data in which you are what you are doing? You are identifying what is your x and what is your y, where y is a dependent variable and x is an independent variable. So and also what you are doing? You are identifying few values for x and y, and you are plotting that into the line. That is another scenario. First try to understand this. So as x is an independent variable, so you have taken the values, and coming to here, y is a dependent variable. I have taken certain fitting function here, 3 plus 4 into x plus np dot random. It's a constant. So to get the constant, or you may call it as a noise. So noise value randomly again I want to take. Some value I want to take randomly. So that constant value I'm picking here. mx c is equal to mx plus c. So as I have a certain constant value also I'm taking, that is a noise, and this is a constant value, whereas this is your x value or independent value through which you are generating your y. So you are generating sample data based on this. Now you have taken a function called matplotlib for this thing. You want to plot it. Step 3 is visualize the data. And it's not important, or it is not mandatory, but to understand how these x and y values are aligned. So how these x and y values you are getting, what can be your x and y, to understand that, you can go for visualization, but it is an optional part for your linear regression. Till here it is clear? This part. Yes? Is it clear? Any doubts you can raise? Now I'm fitting that to linear regression model. As we know what is x and what is y, I just want to call a linear regression model and through model, and in this model I'm fitting whatever the x and y values I got it here from here. Okay, so those values I'm passing here for fitting purpose. Now interpret the model parameters. So now I just want to display the coefficients, model coefficient and model intercept. Already once I have sent this x and y for the model for fitting purpose. So now I'm interpreting the model parameters, which are coefficients and intercept. I just want to display my coefficients and intercept. Can you tell me what is coefficient and what is intercept? Mx plus c, in which is called as coefficient and which is called as intercept? Please fast. Quick. Now I am taking a new x value, some few points, a new x point I'm taking at 0 comma 2, a new array value, and this new array value I'm going to give to the model for the prediction, y prediction. So finally what I want to do, like you have trained your model, you have sent the data, you have trained the model, and finally your model is ready, and what you are doing, you are testing the model by giving the new values. So x new values I have taken as 0 comma 2 values, and these values I pass to my y prediction, where like I pass to the model to predict the y value. So now your y value will be display. So I'm displaying my y value, and that I want to label it. See, initially these are my random values based on which you have created x and y values. No, those values you passed here to in the visualization mode. Okay, so those values I passed in the visualization mode. So here these are my initial values, where my coefficient is this much and my intercept is this much and predicted values. Now coming to the next point, your predicted values of x, you pass 0 and 2 here. So once 0 and 2 are passed, your predicted values of x new value is 3.22 and 11.15. And once you got your new values, what you are doing? So visualize the linear regression line. Now I just want to draw the linear regression line. So which can pass. So which line is correct line? Where many points? Can you please tell me? So we have many lines here. So which line you need to consider? The line which passes among the points, like where much points are connected. You are touching much more points when you are drawing the line. So that line will be treated as the correct line, right? So that is what, visualize the linear regression line. This is what my linear regression line that I am visualizing here, and you are giving the line color, line width and all. Okay. So I hope you are able to understand, and please execute this one quick. So will you execute this or shall I go to the next program? अरे यार respond हो. No one is responding. Why? ఏమ్మా అర్థమైందా? రెస్పాండ్ అవ్వండి. ఎగ్జిక్యూట్ చేస్తున్నారా? థ్యాంక్ యూ.
రావట్లేదు ఎందుకురా?
ఏమి రావట్లేదు? ఎక్కడ రావట్లేదు? సో మెనీ ఆఫ్ యూ ఆర్ డూయింగ్ అలాంగ్ విత్ మీ రైట్? వాళ్ళు మీరంతా చేశారమ్మా? వచ్చిందా? ఎవరో రావట్లేదు అంటున్నారు. వాళ్ళ రెస్పాన్స్ లేదు.
వచ్చింది మ్యామ్.
వాట్ మిస్టేక్ యూ మేడ్ దెన్?
కేస్ సెన్సిటివ్.
అచ్చా ఓకే. Then what is the next question? Naive Bayes, 7th one. ఇప్పుడు చెప్పండి naive Bayes అంటే ఏంటి? So in theory already discussion, like the explanation part is done. So naive Bayes is just like your Bayes theorem. If I say this, will you say wrong or right? The probabilistic classifiers based on applying Bayes theorem, where you have your like strong independence assumptions between the features, whatever the features you are taking, posterior probability, prior probability, like already this thing is done, right? So to make you to understand or to do this program, all the existing data set, even in the Jupyter notebook also we have certain existing data sets. Shall we do with the existing data set called iris? So this entire concept will work with the iris. If it is fine, then okay. So while copying, you people getting problem. So which screen is visible to you? My Jupyter notebook is visible or your manual is visible? Which screen you are able to see? Because I hope I opened your manual, but I don't know whether Jupyter notebook. Fine, okay. Then okay. So shall we start doing the naive Bayes? How much time do we have? Yeah, 15 minutes we have. I hope we can do that. Okay. For that, I just need to import certain packages. I'm importing a few packages here, which I'm copying. Okay. So sklearn.datasets import load iris. So from this sklearn datasets, I'm importing load iris, which is my dataset, and model selection, train and test split, naive Bayes, because I just want to work under naive Bayes, import Gaussian NB. In the naive Bayes, I want to work with the Gaussian NB because naive Bayes, types of naive Bayes classifiers are Gaussian naive Bayes, multinomial naive Bayes, Bernoulli naive Bayes. So like that, we have certain naive Bayes types. in which I just want to choose here Gaussian naive Bayes. Okay. Then we need to load the data set. How to load the data set? Data is equal to load. Do you know the syntax? Quick. Okay. Iris load underscore iris. Shall we check whether we are able to load it? Run. Yes, see, I got the data set, but it is not in the format what we are expecting. Something we got it right. Now we need to convert that to the required format. And the total question they are asking is implement naive-Bayes theorem to classify the English text. So that is the question they are like in your manual we have implement naive-Bayes theorem to classify the English text. Okay. So that thing we need to be remember. Now I need to divide the data. So in terms of X and Y, any concept, any program or any model, so this thing we need to remember. Data in terms of what? X and Y. X is equal to data dot data. And whereas Y is equal to data dot iris. Or you can say not iris actually, Y value always your target. So whether it will be capital lock target or small, that we need to check. So okay, first I'll give the small, then we can see. Okay, then I want to display what is my X and what is my Y. Let me print X. So this is what X and Y. Run it. So together you got it. Okay. And put it as a comment. We'll check the Y so that you can understand. This is X and you try to check your X. So put this as comment and check X. This is what your X. Okay. So whatever the last you have, that value is going to be displayed. So I'm putting this as command and I'm removing this. So now we have X and Y. So we have divided the data. So I think you people are able to understand. I just want to make you to understand how, like, what is X and what is Y without knowing that and whatever the rest of concept I'm explaining, no, you cannot be able to understand. So once X and Y is created, what we have to do, you need to split in terms of train and testing data. So train and test not only X but also Y. So both the divisions we need to do. General partition is 8 is to 20. 20 is for test data and 80 is the train data. So you can, I'm directly taking that syntax because this is a common syntax. So 0.2. What is my test size? 0.2 means 20% I have taken as a test data. By default, what happens? 80% is our training data. Now, I want to create naive-based classifier. Now, we have X and Y and train and test data. Now, I am applying naive-based model. For that, G and B is equal to, as already you have imported, I am taking this one. Gaussian and B. Still people are joining. Okay. So I have imported the model. I have imported the model. Whether it's right or wrong, we'll check. What happened? Y is not defined. Okay, it is small letter. Typo. Okay. Yes. So till here it is correct. So how many of you are able to do the program till here? Simply I have imported the model. Here rain started. I don't know how much time I'll be there in online. Okay. Now fit the model. How to fit the model? We all know. What is the model name I have taken here? I'm fitting the model. Fit the model. Now what I'm doing here? Someone else is unmuted. Please mute at your end. So that is what here G and B. That is what I have taken. Dot fit of what? What I need to fit here? What I need to fit here? Extreme comma Y train. So training data I'm fitting. I'm using to fit. I'm using to fit train data. So execute it. No error. Yes, function called and you started fitting. Okay. And now prediction. Fitting is done. Now you need to predict the test set results. Hash predicting the test set results. So how to do that? I'm taking a variable y underscore prediction is equal to what? So I already our model has been trained. What is my model here? GNB. GNB is the model. What you are asking it to do? Predict. Using what? Using what you want to predict? Quick. I told you not test set. So what it will be? X underscore test. Using X underscore test, I want to predict. Check it. Done. Okay. X underscore predict test. Finally, what I want to do, so you want to check your output, how much you got. So you can check Y prediction. run. Prediction is done. Okay, but we can't understand what are those values because already you have fitted all the values. According to that, you'll be getting the results. Okay, but that also you can check. Finally, what I want to see means I want to see the accuracy. I want to calculate accuracy of the model. I want to calculate accuracy for my model. See, I got 100%. And let me know how many of you got 100%. Hardly 3 minutes or 3.5 minutes is there. So how many of you are able to complete this? But our main, still we have certain logic here pending because the concept is you need to identify the English, what is the question? Classify the English text. So that is there still. But till here, how many of you are able to execute? Oh, quick. Because input I have to give certain English text. So till here the same thing is there, but the data instead of iris we can go for English text. That also I'll show you. But are you able to complete that particular code? Let me know. How many of you are able to complete? This time I have gone for a line by line execution. This time I have gone for line by line. Quick ma. Still a small thing I need to explain. Sample text data for like you need to take completed. Okay. See here. So here also I have taken sample text data for illustration. This is a good book. Randomly I have taken. I like this movie. That restaurant is awful, and I don't like this place. Hi, I'm fine. Certain data, sample data, just like that I have taken. Okay, and almost similar, but here counter vectorization I have applied to convert. Little NLP concepts are here, counter vectorization, because until unless you don't have knowledge on NLP, it is a little typical. Okay. So for that, I have taken like naive base. Under naive base, I have taken multinomial NB. For extraction, extraction of the text data, I have taken counter vectorizer and pipeline because it need to understand the text. Less than a minute we have, and soon try to join. I'll explain this code and the last program we have that also we need to complete within 40 minutes. Okay. Pipeline. Pipelining means the text, whatever the text you are giving, no, that text, how we are converting. So a lot of things are involved when you are taking in terms of text. Stop words are involved, and all the like spaces, full stops, commas, special symbols are there that you need to ignore. Certain things are there, but not completely. I applied here NLP, a few NLP concepts together with the naive base. Okay, please join immediately and we'll continue this.